Hello everyone, my name is Zachary Smith and today I would like to talk about how atoms emit light. First, I'm going to talk a little bit about the history of the atomic model, and then I'm going to delve into the quantum mechanics that you need to know to understand how Niels Bohr's atomic model works. J.J. Thomson developed the first modern atomic model in 1904 based on his discovery of the electron 7 years prior. Thomson believed that the atom was made up of a uniformly distributed, positively charged mass. Throughout this positively charged mass, he believed that there were negatively charged point masses, which he called electrons, evenly distributed. He likened it to the way plums would be distributed throughout a plum pudding, and hence his model was known as the plum pudding model, seen here. His model would stand up and be the modern accepted model for several years until Ernest Rutherford proved it wrong in 1909. Ernest Rutherford conducted a nuclear scattering experiment that showed the positively charged mass of the atom was all centrally located rather than evenly distributed. He believed that the positive mass was located in the nucleus and that the negatively charged electrons, which were much smaller than the nucleus, orbited about the nucleus in the manner in which the planets would orbit the sun, seen here. Rutherford's model would hold up for several years until a few key questions came to light. First, under the current classical mechanical and electromagnetic theory, scientists believed that Rutherford's model could not have been stable. The electrons should have consistently wanted to plummet into the nucleus, but they didn't. It was found to be stable. What was causing this? Second, when these atoms were excited, they emitted a light, and scientists were able to study the manner in which this light was emitted. Using spectroscopy, they were able to see that the light of excited atoms was not the entire spectrum, but rather discrete values throughout the spectrum. What caused this? This is where we need to delve into quantum mechanics to understand why this happened. According to quantum theory, you can create an infinite potential well by creating a large amount of energy on one side, a large amount of energy on another side, and leaving an energy-free space in between. A particle in this well can only move about certain levels if that level forms a standing wave in the well. This means the n equals to 1 state, the ground state, will have 2 nodes, one at either side of the well. Every higher energy state allowed must have n plus 1 nodes. So the n equals to 2 energy state will have 3 nodes forming a standing wave. The n equals to 3 state will have 4 nodes forming a standing wave. The key concept from this theory is that each of these energy levels varies. The ground state will be the highest energy level possible, and every energy level above that will decrease in energy based on an inverse square law. So the second energy level will be 1/4 as energetic as the ground state. The third energy level will be 1/9 as energetic as the ground state. Niels Bohr, a student of Ernest Rutherford, took this quantum theory and applied it to Rutherford's atomic model, seen here. What Bohr believed was that the electrons that orbit the nucleus must take on standing wave orbits. In other words, only discrete orbit values were allowed if that orbit was able to form a standing wave. The key consequence of this was that the infinite potential well theory could be applied to the atom. The ground state, or the lowest orbit possible, would be the highest energy level, and every orbit greater than that would decrease in energy. He also believed that atoms were free to jump between energy levels so long as they gained the energy necessary to jump directly to that energy level. If the difference between 2 energy levels were to be 5 electron volts, an electron could not make that jump if it gained 4 electron volts or if it gained 6 electron volts. It must gain precisely 5. Now, This led to the idea that as electrons jump up, they would eventually like to return to their lowest state possible. Electrons like to be in the lowest energy state possible, in this case, the ground state orbit. In atoms with greater number of electrons, they'll migrate towards the closest state to the ground state that they can possibly get. So, if an electron had been excited and gained energy to jump to a higher level, in order to jump back down to a level, it must lose that energy. In order to lose that energy, the electron emits a photon when it undergoes the jump. Now, a photon is simply a particle that is related to light. It is believed to be the particle equivalent of light, and that its energy and wavelength can be precisely measured and are directly related to each other. Since the energy jump is well known, and scientists know that a discrete energy change takes place, they can study and find the wavelength of the photon emitted due to this jump. Now, since only certain energy changes can take place, and only certain energy values can be found from those transitions, scientists were able to show that atoms could only emit certain wavelengths of light, so that when the spectrum of excited atoms was viewed under a spectroscope, they knew why they were only seeing discrete light values rather than an entire spectrum. And that is how we've reached our modern understanding of how atoms emit light. Thank you for watching.